We are trying to make our structures sustainable so that our footprint as structural engineers is less. And in my view, structural engineers or civil engineers, they simplify lives. Without engineering, this world is not possible. But we haven't projected our image enough to outer world so that they engage with us. But sustainability is at the heart of what structural engineers do these days. And for dealing with climate emergency, we come up with efficient and smart solutions so that our structures are not only sustainable but fit for purpose and demountable as well, so that at the end of life, when we want to get away with the structures, then we can reuse them. So this is becoming quite a norm these days, that we make structures which we can demount at the end of their service lives. Just to give you an example,
Okay, welcome to SQVe Structural Summit, session number 88. And today we are going to talk about composite steel concrete structures. Okay. And today we have Dr. Jawed Qureshi with us. And in fact, he's having PhD in steel concrete composite structures. Okay. So let us get started and let's have a very interesting discussion on the composite structures. Welcome, Dr. Jawed Qureshi, once again on this platform.
thank you, Bhavin Shah. I'm absolutely delighted to be here yet once again. Last time we really enjoyed our conversation, and our audience, they absolutely enjoyed it as well. And this time again, we look forward to having a very great conversation.
Sure. So before we start, can we have your quick feedback about questions or queries or input which you have received from the
Yes.
participants?
There were so many questions. There were 500 questions, and it was very difficult for me to choose those questions. And with these kind of live session, the difficulty is that if the answer to some question is the one-liner question, then audience they would not like it. So I carefully went through questions and selected few questions, and I ended up creating quite large presentation. And it's a technical topic, so in technical topic, it's very hard to keep audience engaged. But I've tried my best to have that engagement in today's discussion. So be prepared, have your pen and paper ready, and I will be asking you questions and I'll be interacting with you. And then some of the questions were about fiber reinforced polymer structures as well, which is one of my another research area. And you're giving me ideas on how to have new sessions. And some of the questions were really very interesting and very thought-provoking as well. So that gave me fresh ideas for research and development, and that created those questions in my mind as well. So I think you really have brilliant audience, Bhavin. And I must thank you a lot for giving me this opportunity to speak to your audience, and some of audience will be mine as well, but the percentage will be really very tiny. And I hope this time that you will pronounce name of my university, University of East London properly, which is in eastern side of London.
Kindly brief what are the composite structures before we get into any discussion.
Yes. Let's talk about what does it mean by composite structures. As you can see in the name, that composite means that when you are combining two materials together, we call it as composite structure. Now that composite structure can be steel concrete composite structure, it can be fiber reinforced polymer composite structure, it can be steel with timber, it can be pretty much anything. As structural engineering is progressing, we are trying new possibilities. What is possible? How can we construct it? And more importantly, in this day and age of climate emergency, we are trying to make our structures sustainable so that our footprint as structural engineers is less. And in my view, structural engineers or civil engineers, they simplify lives. Without engineering, this world is not possible. But we haven't projected our image enough to outer world so that they engage with us. But sustainability is at the heart of what structural engineers do these days. And for dealing with climate emergency, we come up with efficient and smart solutions so that our structures are not only sustainable but fit for purpose and demountable as well, so that at the end of life, when we want to get away with the structures, then we can reuse them. So this is becoming quite a norm these days, that we make structures which we can demount at the end of their service lives. Just to give you an example, I'm sure a lot of you would have seen wind turbines. Wind turbine blades these days are being used as footbridges. So at the end of their service lives, still, and service life is not more than 20 years. At the end of their service lives, they are still usable. Now we have to find another use. And another use is that we use them in footbridges, as beams in footbridges. And then we combine it with other materials, timber, floor, and etc. to make a bridge possibility. In my view, composite structures are future of construction and future of structural engineering.
Yeah, great. Okay, we can see audiences from all different parts of the world as well as from different parts of the India. And in fact,
Okay.
one comment has come that please make a course related to composite structures. Yeah.
Absolutely. I think this topic is really very popular on my YouTube channel. One of my most popular videos, which are very long as well. Normally, long videos, they don't get much popularity. So on the steel concrete composite beams, design of the steel concrete composite beams, those videos are really very popular. So I can see that there's a lot of interest. So yes, definitely. I think I will probably use this summer to create a course using different design codes. American, Indian, British.
Yeah, so the first question is what is steel concrete composite construction? Already you touched upon this point. And where and why do we use composite construction?
When we talk about composite structures, in our mind, we can say that there are two materials. Now, what is the difference between steel concrete composite and reinforced concrete structures? So reinforced cement concrete in itself is a kind of composite structure, but why don't we call it as composite? Now, I will tell you why. In the steel concrete composite structures, we have concrete and we have steel. But same is the case with reinforced concrete structures. Why don't we call reinforced concrete structure as composite structure? The reason is that because dominant material in reinforced concrete structures is concrete. We simply use steel bars where we need tensile strength, isn't it? So that's why we call it reinforced cement concrete. But in case of steel concrete composite structures, we have two materials. And here we are talking about structural steel. By structural steel, I mean I sections, tubular sections, and these are complete sections which are embedded with concrete. In that case, dominant material is steel. So when dominant material is steel, we call it as steel concrete composite structure. Now, why do we use steel concrete composite structures? And where do we use it? And when do we use it? First, why do we use it? The reason is that there is no such material that we can call as ideal material. Tell me one ideal material and I will tell you that it is absolute lie. There is no material in this world which is ideal. Like human beings, every material has got its limitations. What are limitations of concrete? Really pretty obvious. Concrete is strong in compression, but really very weak in tension. Tensile strength is almost probably 10% or less. And how about steel? Is steel an ideal material? The answer is no. Steel isn't ideal material as well. Steel can corrode and steel can buckle as well because the sections are very thin, so when we use them, they can buckle. So all materials have some limitations, some shortcomings, some demerits. Now what do we do in that case? We combine them to make those two materials strong so that they complement each other. And that's why we combine steel and concrete, so that the limitation of both materials can be overcome. And that's why we use it in steel concrete composite structures. Now the major areas where we use steel concrete composite structures is, first of all, steel building. And here I will be focusing mainly on steel buildings. And I will be talking about composite slabs and composite beams in this lecture. I will not cover composite columns. I will talk about it briefly, but not fully. In steel building, as you can see in this picture, we have steel beams and we have this steel member. On top of that, we have this profile sheeting slab. Now here we don't have any other option. We cannot have a complete steel slab. It's going to be really expensive and it will increase a lot of loading as well. So we try to use materials really efficiently. We use this thin sheeting, which is really very thin. You can't imagine it's just 1 millimeter. So we use this 1 millimeter thin sheeting and we nail this sheeting to top of the beam, and then we weld shear studs through the sheeting to the beam, and then we put mesh reinforcement, and then after that we pour concrete. Together it forms a composite system, and we call it as steel beam with composite slab using profile sheeting or metal decking or metal deck. And together it really forms a strong and efficient connection. Now in this case we don't have any other choice, although we have a choice of reinforced concrete slab, but I will come to that in a minute. And I will move to next possibility, which is steel concrete composite beam with pre-stressed precast hollow core slabs. Now hollow core slabs are used where a lot of spanning capability is required, as much as 17 to 18 millimeter column free or beam free space. In that case we use these hollow core slabs. We bring these hollow core slabs on top of the beam, and then the shear studs are pre-welded, and we have reinforcing bar in this gap, and then after that we have in situ concrete, and together it becomes a composite system. So there are three possibilities. One is steel concrete composite beam with metal decking slab having a profile sheeting. Second is steel concrete composite beam with precast pre-stressed hollow core slab. And there is a third possibility as well. The third possibility is steel beam with solid reinforced concrete slab. Now here you can see that we have a beam, and on top of beam we have ordinary reinforced concrete slab. But the difficulty with this slab is that we require a lot of form work underneath, and due to speed of construction in steel structures, especially in Europe and Western countries, composite beams with profile sheeting or with hollow core slabs are really very common, and composite beams with reinforced concrete slabs are not common because they require form work underneath. So these are three types of steel concrete composite beams. One is composite beam with profile sheeting, second is with hollow core slabs, and third is steel concrete composite beam with solid reinforced concrete slab, which we do not use in Europe. And I'm sure I'll ask you in a minute that if it is used in India or not. Now, this system is really very interesting. This is steel CLT hybrid construction. CLT means cross-laminated timber. In this structure, this is Edge building near London Bridge in London. It's a 27-story office building. Here in this zone, play zone, cross-laminated timber, a slab made up of cross-laminated timber is used on top of steel beams. This building is to be completed in 2026. And timber was used for future flexibility so that we can remove this. It's demountable and we can reuse these structures. Now, it is one of the key things that reuse of structures, which will be the future of construction and structural engineering, that we will be reusing lots of material. There will be a lot of emphasis on this area. This has got Barium rating of outstanding. Barium is and LEED, they are organizations in Europe which rate buildings as per their sustainability requirements, and this has got outstanding rating. By the way, this Edge building is different from Edge building in Amsterdam. In Amsterdam, we have Edge building as well in Netherlands, and that has got 98.9% barium rating, which is really highly sustainable. It's got its own electricity generation plants inside, and it is really sustainable building. This is the cross-laminated timber which is used over here, and steel beams, they are supporting this cross-laminated timber slab. And as you can see over here, that at each fourth floor we have some other composite section, and I will tell you what's the reason for that. Removable mechanical fixings were used in this structure so that we can use it in future. At every fourth level, precast hollow core slabs were used so that we can ensure 120-minute fire compartment. So after every fourth floor, we have precast hollow core units. You can see here that the color here is quite different than color of these three floors, and this is precast hollow core slab. The reason is that we want fire resistance. And then I will move to why do we use composite structures? What will happen if we don't use composite structures? And in my view, we get at least 25 to 30% saving in terms of material cost if we utilize composite action. Now, these are three examples: composite beam with 406 178 universal beam, and second is non-composite beams. Here we have 533 210 and 305 305. This is a column section. Now all these sections, they have same loading capacity, and construction height, you can see it's 560 over here, and in case of non-composite it's 710. And for universal beam, normally we don't use universal column in as beams. Here you can see steel weight is 100%. Here it is 60% more in case of non-composite I section. In case of non-composite column section, you can see it is double. It means significant reduction in cost. Construction height. Now construction height is really very important. Here you can see construction height is 127. It's 27% more in case of non-composite beam, and in case of universal column it is 93. It is important to note that stiffness is quite a lot as well. In case of non-composite, stiffness is 72, and In case of column, it is just 46. Can I say that by using steel concrete composite structures, we are able to save materials because steel weight is less. We are able to have less construction height, and we are able to have a stiffer section, which leads me to this idea that steel concrete composite structures, they are strong and they are stiff. Now, same is the situation with columns, but composite columns are not very common. In case of composite column, here you can see that the dimensions are 70 by 70. In case of reinforced concrete, is 80 by 120. In case of a beam over here, it is 160 by 40, and here it is 160 by 120. So you can see that significant reduction in height. I'm not sure about the cost of these, and these type of sections are not very common as well. But steel concrete composite beams are really very common. Now this leads me to a question for you, which is, how many of you have worked on a composite construction project, and what is the most common composite slab in India? So type your questions in comments down below. That was quite daunting. I was just talking to the screen, but hopefully people would have seen me. That's absolutely fine.
Yeah, so the response have started coming now.
So composite deck slab is common.
Composite deck slab. Steel beam with metal decking.
Metal decking. All right. Okay.
Deck slab.
Deck slab.
Then only deck sheeting slab.
Deck sheeting. Yeah. All right.
Yeah.
Okay. So I've worked quite a lot on this.
Yeah.
I have worked quite a lot on this area. I did lots of testing. I'll show you as well today.
Concrete with metal bars.
Metal bars. All right. What does it mean by metal bars?
I'm not sure. So Varun, could you please elaborate this? One more thing.
It's a new thing for me. I want to learn.
Yeah.
Using composite slab with metal decking. Yes.
Okay. And deck slab with steel beams.
All right.
Deck slab. Yes. Also composite column for an expansion project.
Expansion project. All right. Okay. Yes. Absolutely.
Deck sheet.
Deck sheet. Okay.
Okay. Atul Dubey is saying that we are only designing composite joist in deck slab and composite column.
Composite column as well. All right.
Deck RCC slab over steel plate girder in railways.
Is it on railways? Okay, that's interesting. I want to know more about it.
Yeah. Okay, Vasant is saying common practice in India is RC and PT slabs, but using composite slabs are less comparatively.
PT means pre-stressed.
Yeah, post-tension.
Post-tension, sorry. Post-tension. Superstructure, shear stress, yeah.
Steel bridge superstructure with deck sheet.
Steel bridges,
Okay, my work has a lot of steel two-story gantry structure to hold cooling units for data center. Sadly, no concrete apart from foundation. Okay. Okay, someone is saying, I'm now working in a project where composite steel beam with reinforcement concrete slab is being used.
So, Suman, if you have some pictures, then please send it to me on my LinkedIn. Okay.
Sure. Yeah.
Because I don't have any picture of reinforced concrete slab. So some students and engineers, they ask me, where's the picture? So thanks a lot.
Deck slab for large span auditorium.
Large span as well. I would be interested in that as well.
And Prince Verma is saying that steel with concrete.
This is another of research area. I used to work at University of Leeds, and I have a PhD from there as well. So my supervisor there, he used to work quite a lot on steel tubular columns with concrete filled, and they've done huge research on that. Yeah.
Great.